Welcome to the wonderful world of math. My name is Smith, and we're going to do 3.3 today. I didn't have it listed on here, so let's go ahead and add it on. I do apologize, but this is lesson 3.3. And our objective today is to use certain angle pairs to decide whether two lines are parallel. So 3.2, we had our first set of theorems that said if we have parallel lines, then corresponding angles are congruent. And so you're going to write down 4 theorems. Make sure you draw the picture. I want it to look just like this. And our first theorem is the converse. So again, you start out with if you have a transversal cutting two parallel lines, then you have congruent corresponding angles. Now we're flipping that, the converse, and so now we're saying the reverse of that. So if two lines and a transversal form corresponding angles that are congruent, then we have parallel lines. So this allows us to prove lines parallel. That's kind of our goal for this lesson. Okay? So here we have the first one, so write that one down. Boom. So if we have congruent alternate interior angles, then we have parallel lines. So that means L and M must be parallel. So if they're congruent, then we have parallel. Write that one down. Pause, write it down. And you have the converse of the same side interior. So if these add to 180, then we have parallel lines. And last but not least, pause, write this one down. And the last one is alternate exterior angles theorem. My old video used to be 3.2, 3.3, because literally this whole lesson is just the converse of 3.2. So we're just flipping the if and the then statement. But let's do some examples, and let's see if we can figure these out. Okay? Okay. I don't know why I did that, but anyways. Okay, so I like to use colors, highlight, whatever. So I'm going to highlight. I'm going to use green, yellow, green. And here we go. Which lines are parallel from 1 and 2? So we have 1, angle 1 here, angle 1, angle 1 here, angle 1. I don't know. Why isn't it? Come on. Oh, now it goes. Great. Okay, let's try that again. All right. Angle 1. Okay, seriously, it's not even funny anymore. Like, it was funny for a second, but now it's not. There we go. There we go. All right, so angle 1 and 2 are right here. They're congruent. The first thing you want to do is you want to identify your angle, and second, you want to identify what side they're both on. Okay? So, what line they're both on. So 1 and 2 are both on this line right here. So that's our transversal. So because I have congruent corresponding angles, then which two lines are parallel? Well, the answer is going to be the two lines that this transversal, the line that they're both on, cuts. So it cuts A and it cuts B. So that means A is parallel to B. Again, remember, make sure you write the problem, write the picture. Okay, so A is parallel to B because of this. All right, just for fun. I like to always see what happens with it when you hit solution here. You know, ooh, 1 and 2 are corresponding angles. Then A and B are parallel by the converse of the corresponding angles theorem. Excellent. All right, let's look at another one. Whoop. Okay, 6 and 7. So let's go ahead and identify 6 and 7. We'll use the light green again. So 6 is here, 7's here. Okay, cool. What line do they share? They share line B. So which line did this just cut? Those are the lines that are going to be parallel. And the answer is going to be line L is parallel to line M. Okay. And why? Because these are corresponding angles that are congruent. So let's go ahead and erase, see what they said. What did they say? They said, correct answer, L and M by the converse of the corresponding angles. Like, we're awesome at this. Let's keep moving. All right. Flow proof, determine whether lines are parallel. Yeah, that's exactly what I want to do. I'm like, that's exactly what I want to do. It's what I want to do for the rest of my life. Every day of my life. Oh,
In
gosh.
this problem, you will determine whether lines are parallel. The fence gate below is made up of pieces of wood arranged in various directions. Suppose angle 1 is congruent to angle 2. Are lines R and S parallel? Explain.
Whoa. Did you hear that guy talking? Okay, so first of all, that cat, I don't know why they put a black cat. That's bad juju. I don't know. Let's color, right? It said 1 and 2 are congruent. Okay, so here's 1 and here's 2. All right, cool. Those are what kind of angles? Well, they're on the outside, they're on the exterior, and they're alternating. So those are alternate exterior angles, which would make R and S parallel. And how do I know that? Because they are both on this transversal here. And so that transversal cuts R and S, so R and S are parallel by the converse of the alternate exterior angles theorem. Let's keep hearing what they're gonna say. I don't know. Whatever. Let's see. Whoa, what's happening in the picture?
How do angle 1 and angle 2
where am I?
relate to each other in the diagram?
They're alternate exterior angles. We already said that. This guy's slow. Come on.
Angle 1 and angle 2 are both exterior angles, and they lie on opposite sides of T.
Yeah, they do. They really do. And T is our transversal there, so 1 and 2, and they're on opposite sides. That's what makes them alternate exterior angles, which I think he's going to get to.
So angle 1 and angle 2 are alternate exterior angles.
Am I right? Okay. Let's keep going. I'm having fun, actually.
By the converse of the alternate exterior angles theorem,
Am I the only one
two
here?
lines and a transversal form congruent alternate exterior angles, then the lines are parallel.
Duh, that's what I said. It's like this guy wasn't even listening.
You are given that angle 1 is congruent to angle 2.
Yeah, I know. That was like the whole segment. Why didn't you just keep going? Why do I have to keep hitting the play button?
So yes, R is parallel to S.
Bro, I said that like 100 times ago. Okay, anyways. Whatever. It was good. We got it. We nailed it. Let's keep going. Let's throw in some algebra. Why not? I'm good at algebra. I taught it. You took it. Okay. What is the value for x, which A would be parallel to B? Ooh. Okay. Well, by the converse of... What kind of angles are these? First of all, those are same-side interior angles. So, by the converse of same-side interior angles, these two would have to add up to 180. Not equal, but 180. So we're going to do 2x plus 9. I'm having a little difficulty with the pluses. There we go. 9 plus 111 equals 180. Okay, so if we can figure out what x equals here. So basic algebra, 9 plus 11, that's going to be what? 120. Okay, and then we get 2x plus, there we go, and this equals 180. Easy money. We're going to subtract 180 from both sides. That's only going to leave me with 60. And then we're going to divide by 2, which is going to leave me with 30. All right. So if x equals 30, then we would have two angles that add up to 180. Then, by the converse of the same side interior, we would have, drum roll please, parallel lines for A and B. All right, let's see if I'm right. I'm right. Oh, sorry, my work is over it. Boom, x equals 30. You see that? Perfection. All right, guys, that's it. That's the game. We did it. We won. I just want to thank my sponsors. My sponsors are Apple, not the computer company, just like the fruit. Bite into one today. An apple a day keeps the doctor away. So, can't argue with the facts, okay? So, apples, eat them, That's it. Sorry, that was intense.